Hi students, this is Kishore, faculty in ECE department, DBSIT, Kavali. In today's class, we are going to discuss about the dynamic CMOS logic. Already in the last class, we were discussed the alternate gate circuits designed for special applications. So already in first unit and the second unit, we are designed different types of logic circuit, whether they are maybe a combinational circuit or sequential circuit. So that should be implemented by using a MOS technology, metal oxide semiconductor technology. Already in the last class, we seen one special alternative circuit that is nothing but pseudo NMOS logic. So why we are going for special circuits for special applications is, so we will prefer mostly the CMOS circuit rather than this special circuits. But in CMOS circuits, that may take or require more number of circuits, more number of individual circuits, and whenever we need more number of circuits, the area, that means the size of the circuit increases. If the number of components will be increases within that circuit, due to that the power consumption of the circuit is also increases. So if the power consumption is increases, so that will the life of the circuit or the life of the design will not much more longer than the desired one. So to overcome those disadvantages, we are going for some special circuits. In that special circuits, one of the circuit is dynamic CMOS logic. So in this dynamic CMOS logic, it uses charge storage and clocking properties of MOS transistor to implement the logic operations. So here the clock pi drives an NMOS evolution transistor and PMOS transistor. It is a pre-charge transistor. So in this circuit, so we are having a simple CMOS inverter, so that it is a PMOS transistor and this is a NMOS transistor. So these two devices or two elements will drive by clock pi, that by applying the clock pi signal. So the operation of pre-charge transistor and evolution transistor, it is determined by whatever the logic we are applying at the input of clock pi. So in between these two transistors, we have to implement whatever the logic we want to design. So that will be implemented by using the NMOS logic. So for this logic only, here we are applying Vin voltage to this logic. So based on this logic, so we get we have to perform the desired one, the desired logic by using NMOS logic. So based on that is charging and discharging will decide by the Cout terminal. So this is the clear view of the design of dynamic CMOS logic. So whenever we are coming to the operation, so that is so whenever we apply the clock pi is equal to 0, the circuit is in pre-charge phase with the PMOS devices on and the evolution NMOS devices off. This establishes a conducting path between VDD and the output, allowing Cout to charge a voltage VDD. So that means, so coming to that point, so when the pi is equal to 0, condition, so here we are applying the 0 here. That means this will drive the pre-charge transistor and the evolution transistor. Here both of the circuit has at logic 0. So if that we are applying PMOS to 0, then it will be in on condition. On condition means it will be acts like as a closed switch, and this one will be off condition. Off. NMOS transistor will be off condition, that means it will be switch. The PMOS transistor is a closed switch and NMOS transistor is a open switch. So due to this, if the whatever the PMOS transistor will be in on condition, so it will create a path, conducting path. That means the current direction or the voltage will flow from VDD to this point. So then it will be whatever the logic should be present, NMOS transistor will present. So due to this path, the capacitor will charges up to VDD and the output. So whatever the voltage across the Cout is equal to Vout. That means Vout is equal to VDD. That means whenever the capacitor charges the up to VDD voltage, at the time Vout is equal to VDD. So that is the case 1. Case 1 is if the pi is equal to 0, the PMOS transistor will be in on condition and the NMOS transistor will be in off condition. Based on that, the capacitor will charges to VDD. We will get the Vout is equal to VDD voltage. And the second case, case 2 is when the clock pi is equal to 1, the circuit is in evaluation phase. So if you are applying pi is equal to 1 at the input of 2 transistor, so for that case the transistor, the NMOS transistor will be in evaluation phase with PMOS devices off and the evaluation NMOS device is in on condition. So the logic blocks acts like as a closed switch that can discharge through the logic array, that evaluation through evaluation transistor, then the Cout is equal to 0. So that means so here case 2 is pi is equal to 1, case 2 pi is equal to 1 at the time. So whenever we are applying the 1 at this input, so then the 1 will be the input for both the transistors. So here the evaluation transistor will be 1. The input is 1. That means on condition. On means so it will be acts like as a closed switch, and this will be connected to the ground terminal. So whatever the logic present here, so irrespective of that logic, so that both the dynamic CMOS logic will be depend on both the pre-charge transistor and the evaluation transistor. So during case 2 it will be on, so that whatever the voltage appeared across the transistor, so that will be discharged through whatever the logic implemented within the NMOS logic by using evaluation transistor. So this is the operation of dynamic CMOS circuit. So here we have to remember 2 conditions. One is the pi is equal to 0. So at the time the entire circuit will be depend on the pre-charge transistor, and when the pi is equal to 1, the entire operation will be follows the evaluation transistor mode. That means 2 modes, pre-charge mode and evaluation mode. So based on this concept, so we have to design different exercise circuits, we have to design different logic functionalities. Those are nothing but, so here I have to explain 3 more concepts. Those are nothing but 3 input NOR gate. So the logic expression for 3 input NOR gate is y is equal to a plus b plus c whole bar, and the second problem is y is equal to a plus bc whole bar, and the third problem is y is equal to ab plus cd whole bar. So here for the first exercise problem, the solution for this one is 3 input NOR gate. So this will be implemented the logic functionality under dynamic CMOS logic. So the question is implement the 3 input NOR gate by using dynamic CMOS logic. So that is the problem. So for that problem we have to solve the design by using dynamic CMOS logic. So we have to say, so whatever the pre-charge transistor and NMOS transistor will be present within the circuit. So wherever the logic, that means wherever we have to apply the input logic, so that will be at that place. So we have to place NMOS transistor to implement the required logic function. The required logic function. So here 3 input NOR gate. So here 3 input means, so we are having 3 variables. A is the one variable and B is the another variable and C is the another variable. So how many variables present in the expression? So that number of gates will be required to implement the logic functionality. Here we are having 3 variables and we require 3 transistors A, B, C. So why we are connecting parallel means, so here we have the addition operation. That means A ORed with B and B ORed with C. So if that A, the OR operation will present, at that case, so we have to perform, or we have to connect the transistors in a parallel manner, parallel with one transistor to another transistor. In between pre-charge and evaluation mode. So whenever we connect it, and that same as it is, the pre-charge transistor is present within the design and the evaluation transistor present within the design, because of we are implementing by using dynamic CMOS logic. So the same, whatever the difference for this one to this one is, so here whatever the variables present, so that will be implemented this design by using only the NMOS logic. That means wherever the NMOS logic is present, so here we have to modify the circuit, and the remaining things are same for any design we have to design under dynamic CMOS logic. So now I have to explain this operation by using the truth table. Okay. So already we seen the diagram how we have to design a logic function by using dynamic CMOS logic. So this overall operation will depend on this truth table. So here we have to, in this truth table, the following elements are present in the two tables. They are pi and the inputs A, B, C, and the summation of 3 inputs, and the complement of this logic, that is complement of overall y is equal to A plus B plus C whole bar. So here coming to case 1, first case is pi is equal to 0. So we are applying pi is equal to 0 or 1 for to operate in a specific mode of pre-charge and the evaluation mode. So here if the pi is equal to 0, so we are applying the pi is equal to 0. So at that case, so for the both transistor, that is p-type and the n-type transistor, p-charge transistor and the evaluation transistor is in 0 and 1, 0 and 0. So here both the transistors have the input 0 logic. So at the time the p-type transistor is in 0 condition and n-type transistor is also 0. So this will be on switch and this will be off switch. That means it creates a conducting path between the VDD to next logic, and it will be terminated. That is, the ground will be terminated from the entire circuit. So in the case 1, if A is 0, B is 0, C is 0. So whenever we are applying A is equal to 0, B is equal to 0, C is equal to 0. So at the time, at that condition, the both the transistor, that is A transistor and B transistor, C transistor, it should be in off condition. So off means this entire will be terminated, the entire path will be terminated. So that will be opened from top to bottom. So here the VDD, so this will be p-type transistor will be closed. Then the VDD voltage will be charged, that is the flowing across the capacitor. then capacitor, then the output is equal to VDD, that is Y is equal to VDD, then the Y bar is equal to high. The output will get Y bar is equal to 1. If the both the pi is equal to 0 and both the transistors in be 0, so at the time we will get the high, that is 3 input NOR gate, high logic. So that will be happens whenever the pi is equal to 0, so at the time the p type transistor will be in on condition, whenever the p type is in be on condition, so whatever the logic may present, so by following this truth table, so next coming to the second condition 0 0 1, we are applying 0 0 1, so at the time C transistor will be on, but the remaining transistor will be off. And whatever if both the transistor, how many variables will be presented within the implementing logic functionality. So irrespective of the NMOS transistor, we didn't get the logic 0, so that we get the logic 0. Only the condition is whenever the NMOS, that is evaluation transistor, will be on, so then only the entire setup will be entered into the evaluation phase. So second case is 0 0 1. So for that case is also the addition of the 3 elements are 1, and the logic will be, we get the 1. That means so if you want to maintain a sequence for a long time or a definite time, so we have to use the dynamic CMOS logic. So and third case is also 0 1 0, and we get the output is 1, and the 0 1 1 we get the output is 1, 1 0 0 we get the output is 1, and the 1 0 1 we get the output is 1. So that means whenever the pre-charged transistor is in on condition, then the output will be for a long time, that is for some period of time, the output will maintains the 1 logic. So if the pi will be changes, the pi is changes to 1, then the logic will be changes. That means the discharging of the capacitor will charges through any one of the transistor will be on condition, then we can get the output is 0. Then the output is 0. So here based on this logic, so we have to implement any logic functionality. So for example, see for the second case, so here whenever I am changing the pi is equal to 1, then if both the transistor will be in logic high, the input logic high, so for this case it will be off condition, the PMOS transistor will be in off condition. That means it will be open circuited. That means there is no path to flow VDD to output. So there is no path to carry the VDD to the output. So based on that reason, so it will be on condition. The NMOS transistor will be in on condition. So that means it will enter the evaluation phase. So whenever the transistor will be on, so it will be connected to ground. Then the capacitor, if any one of the transistor among the ABC, if any one of the transistor is in on condition, then by using that transistor, the whatever the amount present across the capacitor will discharge through that transistor. So then at the time we will get the output is 0. So why we are using the dynamic CMOS logic is, so we have to maintain some time to maintain the same logic. So we have the best design for any circuit is dynamic CMOS logic. So based on that, we have to implement any logic functionality. Either it may be A is equal to A plus BC whole bar, and Y is equal to AB plus CD whole bar. So here the way of the designing will be changes. why we are changing means here the logic expression is different. That is here B and the C elements are AND with one element to another element, and here another element is OR with A. So based on that, so the design, so the C here A will be series, B and C are series with A. So based on that we have to design any circuit. So in this way we have to design any type of logic functionality. So thank you for watching. Please subscribe DBS Talks.